spacebar to go to the next slide, right?
Probably.
Hey guys, so today I'm going to run through a few, well, pretty much what a relay attack is. This is what you perform when you're pretty much trying to get a foothold onto a network. So generally what you would do is like you would jack into a network, and then you would, well, the tools that I'm about to show you, you start executing those and then just run the whole thing. It's the technique that they use is called pass the hash. It's one of the more common techniques and one of the easiest to actually get a foothold onto a system. And then once you have a foothold, then you begin the post-exploitation using tools like, well, you can use Metasploit, then you can use like PowerShell Empire, Cobalt Strike if you can afford it. But I'll also tell you, I've been kind of testing like all day long, so I'm going to be winging some of this, just so you know. And yeah, also, just so you know, if you have an expression of interest to get the disk hoodies, they're being made. So we've already done our first round, so we'll be bringing those out to whoever's bought their hoodies like as soon as possible. And then like there's going to be another round of hoodies if you guys want some sweet ass merch. Just to
quickly on that
redux
note,
that.
Fucking no, just to add a little bit extra. Like I know it took the best part of a year to get these hoodies happening, due to a long list of reasons. But I finally ordered them last Wednesday, and they're finally on the way. And literally the same day at Sec Talks, I had 4 people from the club ask me if it was too late to get a hoodie. After about 8 months of trying to get hoodies. So if you guys are still keen for one, and you didn't get one the first time, let us know, and we can do it a lot quicker this time. Do it all in one go, same supplier, $60. Done. You'll get them in like 2 weeks if you still want them. If not,
all right. Yeah. Just so you know that for next week's session, we're going to be having a guest speaker, Nigel Hedges. He's one of the head security guys over at Reese. Works over with Aaron. So he'll be talking about how to get a career in cybersecurity. It'd be definitely worth coming along to that one. And also, Hack the Box, the private lab for Deacon is on the way. Ooh, isn't that good news? Yeah. All right, so relay attacks. So pretty much communication on a network which is targeted specifically more by hackers is stuff like the NTLM hashes and also stuff like LLMNR and NBTNS. And of course, the God, I can't say that. It stands for Link Local Name Resolution. It's also it's what came after, or you could say like the sibling or the successor to NetBIOS name service. You're able to listen to these on a network using tools like Responder. And when you're listening to these, you do a technique called poisoning. And what poisoning does is it will, actually, I'll get around to it. I'll get up to it. No, yeah, here we are. I haven't really read much of my notes. So the tool like Responder, which I'll be showing you how to use, is the tool that you'll use when you're listening on a network. Now, the way that poisoning works is that you'll have, say, 2 computers on a network and they want to speak to each other, and you're pretty much almost performing a man-in-the-middle attack to jump in between them to when the computers, one saying, hey, who are you? And the other one saying, like, I'm David, you're jumping in the middle and your computer is going to say, no, I'm David, I'm the real David. And then you'll essentially jump in front of that computer to essentially get the real creds passed on to you, and then you pass it on, and then hence getting access to the network. Then the main way that you perform that is by doing a pass the hash with NTLM hashes. And NTLM stands for New Technology LAN Manager. You also see Net NTLM, which is actually exactly the same. It's just a different way of calling it. And it works the same way as the TCP/IP 3-way handshake, except this is for sort of authentication rather than just confirmation of communication. the cool thing about NTLM is that it actually gets encapsulated with other protocols as well. So the other protocols that it gets connected with is SMB and SMB2, which are the big ones. They're the primary ones targeted when you're performing a relay attack. LDAP, which is also widely forgotten, and IMAP, like all the other ones there. But they're not as targeted. SMB is the big one you want to hit, especially if they're running version 1 of SMB, or even just not even signing SMB at all. All right, so this is sort of what I spoke about a second ago. So the red computer, the attacker, obviously, is what's going to be performing the man-in-the-middle attack. So the first computer will negotiate for the authentication, and then we're just passing that one straight through. Then we get the challenge, and we're sending the challenge over to our victim. It sends it back to us, and then we send it across again, pretty much just listening at this point. And then when the server says, like, okay, you're good, we tell the victim, sorry, dude, you failed, and then we are pretty much masquerading as the victim. Now, the version 1 of NTLM hash is what you can see just up there. It's separated by the colon, and even though it says NTLM, the LM hash, so the LAN manager hash, is before the new technology hash. Then it's pretty outdated, and if you see that when you're on listening on a network, that's pretty good. Like you're in for a good chance to get to listen and perform this attack. Then we've got the NTLM v2 hash, significantly improved from the first one. But yeah, I'll show you what the tools are. I'll run through. I'm pretty crap at doing these demos, so I'm actually literally just going to throw up a video of a person running up the tools which I'm going to show you all together. It literally takes like less than a minute for him to listen on a network, listen for a hash, and then throw the hash up and get a shell. It's really fast, it's really effective, and that's why people tend to use it. So the tools that people use for this sort of attack is Responder and Inpacket. Both of them are Python scripts. Responder is for poisoning the network, and the Inpacket is a library which can do a heap of things, which namely like the NTLM relay is the big one, which is what we're going to be working on. Oh yeah, also after this I'll tell you how to pretty much share with you a link. I'll probably chuck it on the Facebook about how to essentially set up your own little private network so you can attempt to practice the NTLM hash in a safe, controlled environment. So the first one, Responder. Its usage is pretty simply because it's a Python script. You have to put Python at the start, the actual script, so responder.py. The interface, so that could be WSP2E0, I think, or ETH0 or something like that. And what you can see on the screen is Responder essentially listening and getting the hash, which you can see there, which is a NTLM v2 hash, which says administrator and all that. So you essentially just run Responder and you just let it run. You just let it run in the background, it'll do its thing. Just like, oh yeah, that's a close-up of the picture. Just like the Inpacket library, which will do the exact same thing. It's the same, even though I should have written Python at the start, because it's another Python script, but you just put in, say, the T is for target, and then you put in the IP address that you're trying to target. Oh, I didn't have a screenshot of that. Doesn't matter. You'll see it in the little vid. And Envy, or Envy as it's meant to be pronounced, is both of the tools in one, and it only works if you've got Windows because it doesn't work on Linux machines. All three tools are really good at connecting with a post-exploitation tool like PowerShell Empire, which Aaron will be showing you in a sec, or Metasploit or something like that, where you can actually get the PowerShell command and put it inside this tool, in a sense, like you just chuck it in, and it will automatically run through everything for you. So it's like how to get a shell without even trying. That's sort of what it looks like. So in the first one, the first command, invoke env, he's pretty much telling what he wants env to listen to. So for this, he wants it to listen to mbns. And then it's also not showing the output so that he can put in the second command, which is the relay for env. And then it's kind of hard to see a bit, but the sort of greenish colored writing where it says PowerShell, no operation, star, whatever, W hidden, that's the actual command which would get executed inside the victim's machine. So what happens is it's going to execute on a victim's machine when that connects. It pulls up the run command, opens up PowerShell, runs all of that. So like W hidden means that it won't be presented to the user, and then run that, it's not a script, but run that encoded command right there to essentially just grab a shell. And then, sick. All right, so I'll show you the demo. How do I exit this display? That was the... No. What do you mean not that one? Yeah, VM will be fine. So it doesn't click when I type. No. It'll... Yep.
Hang on, we're just... Hey.
All right, so just so you're aware, I haven't... so this screen here, he's going to be running PowerShell, which Aaron will run through with you in a sec, which is the post-exploitation tool. Over here in this screen, they're going to be running through the NTLM relay tool, and up the top is going to be running up responder. So he pretty much fires all three. So he's going to get what the encoded PowerShell is going to look like from PowerShell Empire, and he's going to paste it in and then just run the two, and then it's essentially just going to sit on the network and just silently wait for creds just to fly by, just the hash. And the one thing I sort of forgot to mention about this attack is that part of the reason why it's so popular is that you've got encrypted creds which are flying around, and then once you capture them, you don't actually need to decrypt them or unencode them. It's like, that's the whole reason of passing it along, is that you don't need to have a rig to, figure out what the clear text is. You just pass it on as if it's your own, which is why it's like so popular. It's so easy. You don't need much power to run it. All right, so let's show you this if it wants to work. Yeah, maybe not run it on this VM. Sorry, man. Yeah. Whoa. Yeah. You mind if I get rid of this?
Yeah. No, don't do that.
Oh, yours is Control-C.
No, because it's a Windows.
Oh, yeah. Man, I see Mac. I think Mac. All right, there we are. All right, so there's no volume in this, so you don't have to worry about that. And, oh, that is rough. All right, so just pretty much to get the gist of what's happening. Oh, there we go. Sorry? That's pretty much exactly what he's doing.
We'll go through the whole window on the left in a minute.
So pretty much he's just firing off both of those from the simple usage commands that we showed. And then it's just going to listen for creds to be passed on the network. And then once it gets the creds, you'll see over here that, okay, so the agent's active, but you'll see, voila, we finally got a victim because it finally accepted the creds. It's a simple attack. It can be kind of like tricky to understand and kind of finicky working with a few tools at the same time, like all in conjunction with one another. But it's definitely something that if you have an interest in, or pretty much attacking networks or essentially internal infrastructure, it's something that you are definitely going to encounter, or a technique that you will be using soon. All right, Rafi, you.
All right. Let's do some actual practical stuff. Yeah? No, he didn't hear me. That's okay. All right. Who has used PowerShell for anything before? Ever? Couple? Who has used PowerShell Empire in their post-exploitation fun and games? Awesome, because I was just half expecting all of you to go like, yeah, we use that all the time. And it's like, oh, I'll leave then. But that's good. Just a couple of quick assumed knowledge-y sort of things. I'm going to assume you sort of understand the way that antivirus programs work, especially now since Windows Defender is a pretty good antivirus, which pretty much means that any computer Windows 10 has a good antivirus on it, pretty good antivirus on it. If you don't, more or less they rely on definitions. So like definitions are basically like signatures. If they see a file, anytime, so I'm going to assume you also sort of understand what hashing files. Like if you generate a hash of a file, that's that's basically a unique string of characters that represents that file. If you change one bit in that file, it'll generate a completely different hash. So similar to that, it relies on definitions of files. So if it sees a WannaCry virus and they add a definition to the antivirus, it'll throw that definition down to every client that has that antivirus installed and say, if you see a file with that signature, like kill it, lock it down, it's a virus, it's bad. Works great, but it generally works pretty, there's a traditional antivirus as well. If you want to dig even deeper into the moderner stuff, you need to look at what they call EDR, and I think HIPS that's something to worry about when you have to worry about it. But essentially, if there isn't a definition for a file, basically, yeah, like just by definitions, if there isn't a definition for the file, it'll see the file, it'll go, looks fine to me, it'll let it go. Sort of like this flowchart, you run an executable program. Is this a file that is bad? Yes. Then block it and do all the good stuff. If it's not, HIPS is host intrusion prevention system, I think. But basically, if it's cool, just like you can run. There's more advanced antiviruses have all this fancy behavioral machine learning flappy stuff, but I've been testing a lot of different antiviruses, especially modern machine learning ones like Cylance at work, and I haven't found a single point of difference yet what a basic antivirus has found and detected and what one of these new ones has. Like everything I've thrown at them, they've had pretty much exactly the same detection rate. So maybe they're good, but yeah. File-based attacks and memory attacks. So hopefully you understand the concept of files on your hard drive and stuff in memory. So like our memory is sort of like a temporary storage for things that are running, and your hard drive is like a permanent persistent storage. It doesn't have to be running, it'll still be on the hard drive. If something's running, it has to be in memory. So modern malware nowadays generally tries to avoid touching the hard drive whatsoever because antiviruses look at files on the hard drive. And malware will try and stay just in memory as much as it can and only touching the hard drive when it has to, which means that all the antiviruses have to go, all right, now we look at memory too. And you'll see that as soon as one antivirus company says, we do this, every other antivirus company suddenly does it as well. But just because they say they do it doesn't mean they do it well. Hopefully you have seen this term C2 before, or command and control. And that's, if you haven't, that's essentially a concept where you run a server somewhere in the internet or somewhere that's accessible, and that's your evil command and control server. Like say you're the evil hacker and that's your server. You're going to try and infect systems, and once you've infected it, you'll have an agent or some kind of malware running on that system, and it'll call home to the command and control server asking for instructions or just waiting for instructions, and you'll execute commands there, and they'll run on your targets or clients basically. And that's what we're going to be doing today. Similar to Metasploit, but different. And like this is a link to the sort of summary of what you can and can't do with computers on Australian law. Like the shit that will, exactly, how not to become a black hat hacker. But essentially it boils down to, if you do shit on systems that you don't own or you don't have permission to do shit on, and you get caught or they trace it back to you, you're gonna be in big shit. So unless you're extremely confident that you'll never get caught for anything, I highly recommend staying in virtual labs, running with virtual machines, and doing it in closed environments. And if you ever need help setting up a lab or a virtual lab or something, just shoot a message on Slack and someone will help you. So Empire it's got a lot of similarities with Metasploit, but basically way back when the project started, it was because a shitload of really smart dudes realized that you could use PowerShell to do anything you wanted on a Windows system. And them being security researchers, they went straight to developing exploits and what is now detected as malware by antivirus companies. There's links all over these slides as well. So if you jump in the Slack, you can grab the slides and follow the links. I only just found that cheat sheet like literally when I left work, and it looks pretty cool. So that's useful. What do they have? So their agents try to run completely in memory without touching the hard drive whatsoever. So that pretty much avoids any file-based detection from the get-go. There's almost all of the really good post-exploitation modules and techniques and stuff are already preloaded into Empire as modules that you can use out of the box. It's also extremely easy for you to grab any PowerShell script that you write or you find or you modify, load that up into Empire, and then fire that off on your agents. Obfuscation, we'll get to that. I didn't show the video. Some of you have probably seen this, but this is once you start playing around with obfuscation, this is kind of what it seems like when it says free antivirus, but even the enterprise grade antivirus that you pay thousands of dollars for seems a whole lot like this. I think someone posted that on Facebook and I love it.
You still need antivirus, but I think the moral of the story is don't rely on it for everything. I think so. The three main components are the three main concepts are listeners, stages, and agents when using Empire. And then there's the modules when you're interacting with an agent, but it's all really easy to use. Like, so I've got, in theory, so I have this server. So right here I've got a server in the Google Cloud hosting platform. So it's just like Amazon. Fun tip, if you can have a micro Linux server on the Google Cloud platform free forever until they change that terms and conditions. Like the lowest level one, no cost whatsoever. It's an unlimited trial period, so free server, nice. On the right, I just have a Windows 10 VM. It's got everything on. It's got the firewalling on. It's got the latest Windows Defender updates. You can see nice and updated. I'm not going to sign in. Sweet. As up to date as possible with today's definitions. Is that good? God, that's slow. So, here I have Empire. There's setups and stuff on the website. It's super simple to get started. Just follow the instructions. But once it's all set up and ready to go, you've got this Empire binary, and you just give it a run. This is incredibly slow. Hey. So, listeners. A listener is basically, if you use Metasploit, it's like the multi-handler exploit module thing. It basically, you set it up. Once it'll listen, it'll open a port, it'll listen to service, it'll open a listening service on a port, and it'll wait for incoming connections. And once any incoming connection that it receives, if it passes the test of saying, like, it's all pretty cryptographically secure, so not anyone can just connect to your listener, but once it receives a connection, it'll send the rest of the payload back and establish the agent, and then you've got a foothold on that system. So the listener is just like a listening service. It's the server part of the command and control. So just a quick note, any of the commands in Empire that have use X, to see all of the all the possibilities for it. Oh wait, I think I need to. So I've got one running right now on a free DNS, but I'll just turn it. God damn it! So I'll turn that off for now. All right. So creating a new listener. You basically hit space, use listener, and then you can press tab twice, and it'll show, just like command completion in the terminal normally, it'll show you all of the possible ones. So you can even run a Meterpreter multi-handler from here and manage your Meterpreter like shells or agents from here if you wanted. There's a lot of crossover between C2 thingies like Empire and Metasploit, but generally they work together as well. You can sort of use them interchangeably for certain stuff. There'll be some things that Metasploit is a lot better at doing in situations, and there'll be some things that Empire will be better at. But today, we are going to we're going to create a HTTP service listening for an incoming HTTP connection. So we have selected the HTTP listener. If we hit info, this is basically where we can set all of the variables for it. So you can see whether they're required, true or required, true or false. It's, if it's false, you don't need to set a value for it if you don't want to. So I'm going to leave this like this should look familiar to you from when Chris was talking. This is, if you see this, they're basically a couple of flags for the PowerShell command or script that you're going to run. What they stand for is the NOP stands for no profile. It's basically saying do not start this process under this user, or don't associate it with this user's profile because that might be a bit sus. So just launch it as you're still launching a process that the user owns, but it's just on the PowerShell side is not associated with that. Start in single-threaded mode. The W1 is important. That's the same as saying W hidden, and then basically says don't show a window when this runs. Just show it. Just leave it as a hidden window. So if it executes properly like that, the user will never even see anything. And then the ENC basically means that the following command is going to be base64 encoded. So if it's not, anyone guess why we might want to base64 encode this? Anyone? Why might we want it to look like a base64 string rather than what? No. So, not quite. Not quite. So base64 is like, if you had so I've got a file named test, and the string in this is apples. If I if I base64 encode that, it turns into this. If I base64 decode that, then it turns into apples. It's not encode. So basically the answer is this is generally used a lot in like network, when communication between networks, or sending data around remotely, because it basically, this is kind of a bad example because it doesn't, but it basically makes it way shorter. If I echoed oh wait. Oh, why did I put a semicolon in there? Oh, there's another one? Are you fucking shitting me? Cool. Now I... Oh, come on. Bad example. But if you have a shitload of text, basically it will, if you have heaps, it'll make it shorter. Because when we're either copy pasting stuff into PowerShell or trying to run stuff in PowerShell, we have a character limit of like 2,000 or 3,000 or something. Base64 could kind of be considered obfuscation, but it just base64 encoding and decoding alone wouldn't. MSF Venom encoding. I think that's for. Yeah, I think the basics. I think the encoding, like the Shikata Ganai encoding, is that what you're talking about? Like, I think that's more for obfuscation, but there isn't really enough. What do you call it? Like variance, I guess you could say. Not that. You know when you're doing random generation and stuff, there's a term used for. It sort of means like the number of possibilities that kind of like that. There's not really enough permutations just using base64 alone to sort of dodge AV definitions. Like once one of them is detected and defined, then whoosh, it won't work. Anyway, we're getting hung up on this. Base64 would be a part of obfuscation to a bit, but in this case, it helps a lot with that. But let's just look at the settings that we need to get our listener up. So we can call it whatever we want. We can, the launcher, we're going to leave it as the default because it works. The default delay is the agent delay / reachback interval. So that's basically the number of seconds that it will wait before it beacons home to say I'm still alive to the command and control server. So with this, it'll talk home every 5 minutes and say, hey, I'm still here. If it misses 60 calls, then it's just going to kill itself. Working hours, I don't know why anyone would use that, but you can set like hours for it to be alive for. I like forever better. I've been trying to mess around with the Slack stuff, the Slack integration that'll send you like an alert to your Slack channel when you get a new shell, but I haven't got it to work. We're going to leave the defaults for a bunch of stuff. The default profile, we'll leave that. The host is important. So this is saying this is the address that the agent is going to connect to when it initially, executes. It's going to go to this address for. So you can't see it's a bit cut off, but I've got my DNS name that will point to this server on port 443. So using common port names like port 443 or port 80 is probably a good idea because that, I guarantee no one in any corporate world has made a firewall rule that says you cannot talk to websites on port 443 unless they're very, very paranoid. So it's probably a safe bet that that'll work. If you're doing this on your little sort of local lab or virtual lab you don't have DNS associated with, you could probably just put HTTPS and then the IP of this server and then port whatever. We'll go through the cert. I'll go through the cert thing real quick at the end if we remember, but this is basically making sure that all of your, so this is just the location of the TLS certificates. Really easily to use. This basically means that all of your communication between your server and your clients are all encrypted with TLS. Like, website grade, awesome. This is what a lot of websites should be using nowadays, but we can do it for ours as well to make sure that no one can snoop on the communications between it. Which is good when you're doing pen testing because you don't want like sensitive information flying up and down from clients, but it's even better for this because you can't sniff it. Like if you did TLS inspection on everything at your firewall level, then you might see it, but if you don't, no one will be able to determine that this is command and control traffic because it's all encrypted mutually, which is dope. The default jitter is basically just a bit of randomness. 0.7 is what people recommend to use, so we're using that. I'm definitely going to block this out, or I'm going to generate a new one after this because stay away from the staging key. I can hear someone copying it down. But the staging key is basically a unique string, and unless an agent gives you back this string when it connects, you're just going to ignore it. So only your agents will be able to actually establish. So this is the IP that you want it to listen on. This is the port you want it to listen on, the server type, so we'll just go with Microsoft IIS. Once we hit execute, it's running. I can test this if I try and connect to the site. It's like, oh, that's fine. We don't need it to be signed. If we go ahead anyway, it's the default Microsoft IIS server. Pretty cool. I'm still really paranoid that there might just be a vulnerability in this server and it'll like pop my server, and then pop Empire, and then, but here, when we're back at Empire, we can see that some IP requested the favicon icon file from the site, but there wasn't anything else, so weird. So we know it works. Any questions? No? Stages are stages are the initial payload. By the way, like this is all post-exploitation stuff, so everything that I'm talking about today is assuming that you've managed to get some level of compromise on a computer. You're either able to execute code or you're able to execute, run commands. You've either got code execution or command execution. So a stager is basically your initial payload. If you have code execution or command execution, you generate your Empire payload. Pizza. Are we doing pizza? Are we doing pizza? Should we do pizza? Hands, how many people would? Everyone but you. Hands, who would hypothetically order pizza if that was an option? All right. Do you guys remember the URL? Don't worry, we take it from your. I don't. Oh. Yeah, I'll put up the URL real quick, and then you have until Chris orders them to. Hey, all right, cool. It's all right. Got it? Yeah. Going. Yeah. All right. You're teaching next week, so. Yeah. Oh, yeah. And then you're just going to start doing like push-ups. All right, order pizza, and Chris will order pizza. Let's just blast through this real quick and then like actually fuck up some shit. So just quick note, there used to be a PowerShell Empire and there used to be a Python Empire, and then like every other thing that sort of worked really well for post-exploitation, they just merged it into the one big Empire project. So now we have both PowerShell stages that work on Windows computers and Empire stages that will work on Linux or Mac computers. So we can pretty much hit anything we want if we want. So if I wanted to generate a stager for my listener that when executed will talk back to my listener, I can just use a use stager. If I want to see what is available, You can see we've actually got a bunch that we can choose from. Dude. Porn with headphones, dude. So this is all of the stages they have by default. The sort of the original raw default just PowerShell one is nah, dude, you missed it. Nah. what he said. Yeah, pretty. I probably shouldn't have, but I pretty much spent like, I think I did like an hour of work today, and then like, sort of half-assed made this presentation over the rest of the day. All right, we're gonna use a stager. We're gonna use the multi-launcher stager because this is the most basic sort of one. But if you wanted to generate a Python one for Linux or OS X, you'd use one of these ones. Probably the OS X launcher would generate a Python payload, which would work on either. There's other cool stuff, like you can generate Windows macros, which you can embed into documents, which by themselves are a bit average. You want to obfuscate those further, but you can play around with that if you want. But once we've selected the multi-launcher payload, we've got a new bunch of options that we can set for that. So looking at the default options, PowerShell language, true, sweet. Base 64 encoded, yeah, why not? We can specify a file to output the payload to, pretty similar to MSF Venom. We'll come back to that in a sec. The other main one that we're going to need to do is set a listener. So this is basically giving it the name of the listener which exists and is online that we want this stager to connect back to. So if we set listener to that, we're going to leave proxy as default and user agent as default as well. But just as an example, let's see what it spits out. So we've asked it to give us a base 64 encoded payload and nothing else with it, and it spits this out. So here we can see it's got the PowerShell things at the start. So all of that, and then everything that follows is the entire thing base 64 encoded. Actually, let's turn base 64 off. This is basically our stager in one command. Essentially, this is a PowerShell string which will connect back to our launcher or our listener, grab more instruction or grab a second stage, execute that, and then be running an agent. But just interestingly, something worth noting, you notice that some letters it looks a bit weird. You can see that some letters are capitals and some just seemingly randomly capitals. There's some strings that are broken up, like get field, but there's some other characters just sort of jumbled in there. There's other random unnecessary things like, there's a good example. Here's a good one, like breaking up strings. This could be one string by itself, but it's not. They've decided to break it up by adding a plus in the middle for seemingly no reason. This is just one layer of obfuscation that it does for you by default. Like it's not enough to get by AV, but it's just worth mentioning because it'll multiply all the possible permutations down the road by too many. If I did the same thing again, you'd notice that you should notice that it's already different. It's already somewhat randomized. You can see this assembly looks different to this assembly. Even though it's exactly the same payload, it's already pretty randomly different. So if we let that be base 64 encoded, let's just see what happens when we try and run it. So, or even better, let's just grab this. So, this is a PowerShell command. Let's say we found a way to execute a command on this computer, and we decided to feed it this. Interesting. Can we zoom in? Can you see that? Can you read it? This script contains malicious content and has been blocked by your antivirus software. So recently, in more recent PowerShell versions, they've added all kinds of security features. One of them being it'll hook into your local antivirus and run anything that you try and do by the antivirus before executing it. So the antivirus has seen this and gone, fuck no, no way, don't do that. It's a pain in the ass. We didn't get an alert for it, but yeah, we know that it didn't like that. We could try the base 64 encoded version, but I wouldn't expect much of a difference. Ugh. Let's just do this like a caveman. Fuck, where's my cursor? Oh, where did it start? There, yeah? Maybe. Malicious content blocked by your antivirus software. That's annoying. We really would like to execute this if possible. Enter the Invoke obfuscation tool that was written by another dude. This tool in itself is really awesome. He published this a while ago, presented it at a thing, but it's basically a tool for obfuscating anything PowerShell. And it provides not just one level of obfuscation, but it provides you about 15 or 20 different methods to obfuscate your PowerShell, and you can combine those methods in any order or number you want on top of the first level of obfuscation. I don't even know how many possible combinations there could be for the one payload, but I promise that antivirus is never going to make it. Like, it's just, it's great. And again, like every other thing that seems really cool, another guy thought, hey, that's awesome. I'm going to bake that into my fork of Empire. And then it worked, and then Empire saw that, and they're like, we're going to merge it with our big project. So now it's just by default in the actual Empire. So now it's as easy as just saying, I want to set obfuscate to true. And really important, I literally dicked around with this for weeks trying to get it to work, and I couldn't get it to work. And then one pen tester told me, oh, because it's not documented anyway, by the way. The documentation for Empire is shit. They didn't write anything down. You just have to figure it out. But this dude literally told me, to get it to work, all you have to do is type obfuscate true, and then you just, oh, god damn it. All you have to do is set the obfuscate command to nothing. That's all you have to do. You just have to set it to that. And then, when you go and execute it, assuming you have PowerShell installed on the server as well, it'll just spin up the Invoke obfuscation tool alongside this to let you just obfuscate your thing on the fly however the fuck you want. So it'll grab that payload that it generated and pipe it straight into this Invoke obfuscation tool. And this is really easy to use as well. It's got all the commands right here. All we really need is show, reset, wherever reset is, reset, out might be useful, and back. That's all we need to really navigate this. So I'm going to type show, and that's my payload currently. That's my PowerShell payload. As you can see, chuck it in there, Not a chance. Now, we've got a bunch of different things we can do to it. There's token obfuscation. These are all different methods. You hit all, it's just going to do all of them in a random order. And this just does shit like, this will execute exactly the same instructions as that on the right, but it just does the most random shit to it. It'll break things up into random values. It'll screw around with strings. It'll reorder strings in the sentence. It will do, if you really want to read up on it, read through the documentation, but it'll create variables where you don't need variables and just mess it all up. And that's one possibility. If we reset that, go back. My favorite is the encoding ones. It'll encode it with, if you encoded it with ASCII, I don't know, I feel like this would be too big. It'll tell you if it is. It's too big. 16,000 characters is too many. But octal is always a good one. I haven't found a payload yet that hasn't just run by obfuscating once with, don't be like that. Am I typing it wrong? Oh, right, I'm retarded. You just press number 3. That's too big. Reset? Did it reset? Might be because there's 9,001 characters hidden in there. That's always good. All right, let's not do that. But let's just try the token all that we had before and see if it works. There's also string encoding. There's then the character type encoding, but remember the token all one options in this because it'll come up later. But just this alone will add so much randomization to it that good luck. Now, if we hit out, we can specify where to output this payload to. I hope I can use home because I don't know the direct. Home. Sweet. All right, I'm going to jump back over. We have payload. So this is our new payload. Let's just see. So yeah, generally it wouldn't be that weird for pen testers who are, they've got a target and they're going to do a bunch of recon. They're going to find out what systems they're running, what OSs, maybe what versions, but more importantly, what antivirus they're running, what protections they're running. So then they can go back, they can boot up a virtual lab at home, they can install it in everything they know about to simulate that as best they can, and just going to start throwing payloads at it to see what works. Once they have a couple that stick, they know that with pretty good certainty that it's going to run in that environment. So assuming that we have, I don't know what Deacon runs, but it, oh, God damn it. The shell is pretty crap. What are you doing? Oh, that looks good. I like it. Hypothetically, oh, that's... It's not a bad idea. Well. And the bracket. Before I execute this, just gonna jump back over to this, because I think it'll work. If it doesn't, we'll just try again. But if I execute that, run, oh, it's got a bunch of errors. However, we see some activity here. Something has called home. It's gone, sweet, that's good. We're going to send you another stage for the rest of the agent. So the initial stage of code doesn't have to be the whole thing in one. All it has to do is execute the instructions to go back, grab the rest of it, and then execute that. So that's all that is. And the rest of the stage is all of the other code that involves what our agent is that will sit in memory. And then we see that a new agent with a randomly assigned ID is checked in. It's now active, and then it sends another stage of more stuff. Any questions about stages? Nah. Now the fun stuff happens. Now we have a foothold on the system. We can start doing stuff on that system remotely. We can start sending it instructions. We can start telling it to execute code, which is technically all you can do, but that's a lot of stuff. If we go over to the agents menu, we get a bit of info. So, does that look a bit nicer? So the name of the agent, that's what we use to interact with it. This is the name of the machine that it's running on. Like the if we go over here, why am I not using my mouse? If I right click on that and go system, see this is the computer name right here. So very handy to know what you're running on. The user that you're running under. So just like you see here, if you have an agent with admin level privileges or root privileges, it'll have a little asterisk there. If not, it'll just be like pretty crappy privileges. So generally when you're running stuff on your computer, you know how if you try to install a program or you change a setting or something, a little pop-up will come up and say, you need to, it'll have a little shield on the button and it'll say like, you need to, I don't remember what it says. But basically that thing, it's like you need to provide admin access to do what you're trying to do now. And generally on your home computer, you can just go, yeah, cool, no worries, have all the access you want. But like in an enterprise environment, it won't just let you say okay. It'll say you have to put in admin credentials, or you have to put in the credentials for an account which is recognized as an administrator account to do what you're doing. And if you don't have those credentials, it won't let you. If you do have those credentials, then you've already got admin. What are you doing? But we don't have those credentials. So interacting with your agent, basically, we have one agent here. To do anything with it, we are just going to go interact, and it'll select that agent. Here's, like anything, type help, and it'll show you the available commands that you can use for the context of what you're in right now. But if I just want a little info about our agent, you can see that, so this is just a couple of Empire stuff, a couple of Empire things, hostname, ID, delay, so we can change any of these as we want. If we wanted to stop communicating every 5 seconds, we could just say, all right, slow it down to every 30 seconds or every hour or whatever. The username, just a bit of info. Windows 10 Pro. Yeah, that's kind of all we get from here. But a couple of commands, you can kill them. Killing it will tell the agent to just remove itself from the computer. Removing it will just get rid of it on your end, so you stop worrying about it. The use module one is where the fun begins. Like everything, yeah, so sysinfo will get you a bit of stuff. So you notice that when we give our agent commands, I think unlike Meterpreter shells, I could be wrong here, tell me if I'm wrong, but I think unlike Meterpreter shells, it doesn't execute that command or instruction straight from that process where the Meterpreter shell is sitting. It'll spin up a new process and it'll try to execute it from there. So if that process gets caught, killed, and removed by the antivirus, it won't remove your initial agent, it'll just kill that process. So if I go sysinfo, you've got to wait a little bit because it'll take a few seconds, but yeah, we already know all that stuff. So yeah, you can manage all of your agents from here. It'll interpret some basic Linux commands as well. So if you try and do stuff like PS, it'll return all the processes. If you do pwd, it'll work. If you do, you can cd to change directory. Let's let it. So process list is really interesting because we definitely want to know what other processes are running on the system. Let it run the pwd. So the directory we're currently in is the C users Aaron. I guess it's pretty good to know what our current process ID is as well, but that's fine. So it'll interpret some Linux commands too, like rm to remove files or that kind of thing. And then modules. So if you ever get to this stage, you can basically do whatever you want on the system, and you can start using all of the methods and techniques that like work on, you know, the most up-to-date modern enterprise level stuff. So the modules are sort of broken up into a couple of categories. So you've got credential stuff, lateral movement for once you either have credentials or you've found something that might be vulnerable to move laterally to. There's probably a module that'll let you do that. If you want to establish persistence on the system, escalate your privileges, all kinds of stuff. Actually, only today, I've realized that there's a new category. There's a category down the bottom called trollsploit, and it's what it sounds like. So yeah, some of them include Mimikatz. If you've never heard what Mimikatz is, you need to know what Mimikatz is. It was a tool released a few years ago, and it's been developed since, but it basically it completely shook up the entire world in terms of security because very simply, there's a process in Windows called LSASS where all of the credentials are stored. Like they're in this very secure process up in the kernel, and all of the credentials are stored there. Like when you enter in a password, it'll consult that process and say, was this correct? Awesome. So it has the credentials in there. Mimikatz does a lot of stuff, but the main thing it did when it came out, it basically, if you had admin privileges on the computer, you could dump the credentials from that process in plain text. So if you get root on a box, you can literally run Mimikatz and it'll give you all of the credentials for anyone that's ever logged into that box in plain text, which you can then use and just start logging into other stuff. That's kind of changed a bit now. Mimikatz has lots of other functionality too. That's just one thing that it does, but just as an example, that's read up about Mimikatz because if you ever, yeah, you'll use it. The Bloodhound, Bloodhound I'll touch on briefly, but you can run the ingester from here remotely on your agents. Persistence, Privesc, power up. Powersploit modules are, Powersploit's this incredible library of modules that these guys built, and they basically baked all of that into Empire, so you can just run them straight from there. So yeah, and then if you're a complaining little bitch like this guy, and you have an agent, but you start trying to run like modules and stuff. Privesc. Let's just, oh, I've already, yeah, no, it won't work. You start running modules, but every time you run one, Antivirus picks it up and goes, hey, that's a really shitty PowerShell script that you're running. You shouldn't run that. That's bad. You can pre-obfuscate all of your modules before you even start using them. So if you go to the main menu of Empire you just type pre-obfuscate and then hit yes. It will go through every single PowerShell module that you have, and it will pre-obfuscate it with the token all one settings. And if that doesn't work, you can just pre-obfuscate it again. It'll randomize it again if your modules start getting caught. It takes like 3 hours, so do it overnight. But it basically means that most of the modules that you'll run, even though they've been run a million times before over the last couple of years on every system, and they're very well known and detected, it'll just evade antivirus. Unless there are some cases like where you have behavioral-based stuff, and in the example of Mimikatz, if like, so you run the script and it's pre-obfuscated, and it'll go past the AV, but if the AV is like watching the LSAS process and saying anything that talks to that isn't something that I'm aware of, then kill that too. Like, it's a case-by-case thing, but most of your modules will just slip past antivirus. This is probably something that you'd want to do by yourself at home, and Google every single one of those terms one by one until you sort of have an idea of what each one does. But basically, this is a really sick flowchart which maps out almost all the ways that you can escalate privileges, or that I've ever seen locally, or a lot of the common ones that you want to try first. So that's sitting with an account that doesn't have very much permission to do stuff, but you're trying to become authenticated as an account which has system level privileges that can do anything without, like, just on that local box. And there's a couple of good tools you can use for that too. The broot project is a collection of scripts for every operating system that you can take and run. If you load it up into your, Python might not work. There should be a PowerShell. But you can take that, load it up into your Empire agent, run it there, and the broot project will basically, it'll go and check most of these possible things. It'll go out and check whether the system that you're on may be vulnerable to most of that stuff. And then it'll come back and tell you, and then you can work through them one by one and try and escalate your privileges through different methods. The power-up scripts from the Powersploit are under there too. This one is a favorite, just as a little bit of history. This is still very, very common in corporate enterprise networks now, just because it's a sort of an age-old thing, but it's very hard to remove. Back in the day, group policy used to be used to deploy accounts to every machine in your fleet. Like, you could just, as a Windows sysadmin, you can go in and say, I want to create a local admin account with the password 123 on every system. And if he needs to change that password, he can change the password and it'll update on every system. He doesn't have to go through it one by one. So the way that group policy works is that on the domain controller, which every Windows domain joined computer can access, it stores a bunch of XML files on this directory called sysvol on the domain controller. So, and that's kind of how it works. For it to apply to every computer, they all need to have read access to this folder, right? And it's all stored in XML files. So the account passwords that you're trying to set these accounts to would have their password stored as under an attribute in one of these XML files. But you wouldn't want that in plain text, because then anyone would know the password. So every single one of those passwords in the XML file was AES 256-bit encrypted with a single key that only Microsoft knew. See where this is going? So if only people with access to this key can decrypt the password and find out what it is, and then they can view it, right? Using a single key for everyone also means that every single organization in the world that uses this feature all rely on this single key for the security of their accounts. And then in 2012, they published it on their Microsoft like forums. They gave us the key. Somebody went and published it, and it's still there today. There's a link to the AES key to decrypt everyone's passwords in sysvol. And that's it. Anyone who still uses that or has used that in the past still has their passwords for accounts sitting in sysvol. There have been patches like a few years ago, I think a year or two ago, that made it impossible for sysadmins to use it anymore. Like it used to just come up with a warning saying, hey, that's a bad idea. Like it's vulnerable now and people do it anyway. Then they released a patch that made it impossible. You can't deploy accounts like that anymore. But anyone who has done that in the past, so that's one method to try and escalate privileges. That's a fun one because it's like the first one you do when you get on a Windows box. You say, are there any passwords sitting in essentially plain text on the domain controller? And if you come back with some results, you try those and yeah, see what happens. Windows 10 has made this a lot easier, but anything Windows 7 and older is bad news. Because Windows 10 made it very easy to do this in a more secure way, but they just left Windows 7 behind. And how many organizations still use Windows 7? Yeah. Persistence is the idea of, so I've got, persistence is basically that when I have a foothold on this system now, I can do whatever I want. But if I restarted this computer or I killed the process somehow, I've lost it. I no longer have access on this system. I'm basically back to scratch. I have to re-exploit either the same vulnerability, or if that's been patched, I have to find a new vulnerability and somehow get hold on the system. And if we see that it's starting to yellow because it hasn't checked in longer than 5 seconds, and eventually that'll go red. So for persistence, there's, that's no good. Here's just a couple of examples of pretty common persistence that works too much. It works way too often. The registry is probably the oldest trick in the book. You follow this link, it basically does a rundown of these plus a couple of other ones. But the registry one is like, it just creates a registry entry with our payload. It'll create another registry entry in this, under this, which so the Windows current version run is basically a list of registry entries that will execute when the system logs in or boots up. So we create a key in that says execute this payload, and then every time the system starts, it'll pop us a new shell. And this shouldn't work. Any modern organization should not let users create their own, but it'll work. Unless they've specifically gone and set a bunch of settings, it may work. So as an example, and like if AV picks us up, that's good, because it means that security is kind of heading in the right direction. But if it doesn't, yeah, not great. So if we jump onto this, and we're going to use module, it's a persistence module. These are all of the, so again, before you ever execute a module, don't just execute it if you don't know what it's going to do. Because there's good odds it might just not work. I mean, if it's on your virtual lab, you can do whatever the fuck you want. But like, if you don't understand what it's going to do, there's no point in just running it, because then you don't know if it's going to work in other environments, or you don't know what it's dependent on to run. But just as an example, persistence, what do we want? Userland. So the userland is a common term basically saying that I'm using an unprivileged account. I don't have root or anything. That's sort of the userland. And then there's elevated for if you already have root. So if we go userland registry, just like everything else, once we've got something selected, we can go info to see the settings. And right here we can see we have a bunch of non-required things. One thing we do need to say is set the listener. So this is the listener that it's going to call home to and execute on. If I, just to show you, if I did this and just executed it now, this isn't going to execute the big obfuscated awesome launcher that we've generated before. This is just going to do the default, just the default launcher, and we'll see if it works or not. It shouldn't, but it might. This message is really important. In red, module is not OPSEC safe. Are you sure you want to run it? That's Empire telling you that I'm completely in memory now. I haven't touched the file system, but what you're about to do is either going to touch the file system or it's going to leave traces behind. So obviously, adding a registry entry is going to touch the file system. So it goes, are you sure you want to do that? And since we don't care, we're just going to tell it to go do that. I'm hoping that Windows Defender is going to go meh. I'm going to assume that it didn't work. I just really hope that it didn't work. I don't know how to check for shit in this new bullshit layout. I didn't pay for it. But assuming that Windows Defender picked it up, which we hope it did, that's what this external file setting is for. This is an external file for the payload to be this is the file that you are going to store in a registry entry that it's going to execute on boot. So as an example, so since we already have this pre-obfuscated awesome payload that we know works, we can just tell it to use that instead. So home as a do payload, if we set external file to what? Okay. All right, so we're just, oh, okay, yeah. Of course, Windows Defender wouldn't have picked that up because it didn't execute the payload. Like on boot, it'll try and execute that, and then Windows Defender will be like, what? No way. But if we do that with an obfuscated payload, and we reboot this computer, in theory, we'll get a new agent back because the obfuscated one worked, and Windows Defender will pick up the shitty one, but we'll see what happens. But just quickly, as a couple of other techniques, scheduled tasks will create a scheduled task. This whole left column is under, like, it'll only be under the user's context. So when this user logs into the system, when this user is active, a scheduled task will execute a payload at a certain time of day. I haven't used this backdoor link one, but it's an option. It's basically takes any Windows shortcut that you pointed at, and it'll embed a payload in the back of that as well, or it'll add a launch option, so that when someone clicks on that link, it will still open the link, but it'll also execute a payload. If you get root on a computer though, like if you have admin privileges, you are doing very well. There's a bunch of other, so using the same ones but in an elevated way, the registry will act very much the same, but it won't just execute when this user logs in, it'll execute when any user logs in, because it uses like the system, it'll set it as a system registry key under a different, like under a system directory rather than just the users. The scheduled tasks works pretty much the same, except you have an additional option. You can set it to be on logon rather than just the time of day, which is really awesome. And it will run as system. So when it executes that payload, it'll actually give you a root shell back so you don't lose your admin privileges. And worth noting as well, the registry ones, since it executes PowerShell.exe in a pretty vanilla way, a pop-up box will actually appear for the user while it executes, and then it'll disappear on boot. But if either of the scheduled tasks one, it'll run it in the background, and there won't be any pop-up box at all, so the user will never know that this payload was executed. And then there's WMI, which is probably the best. by far. It'll create a WMI script, and you can set that to start up, and it'll run a system. If you have an obfuscated payload running as a WMI script on boot, you've pretty much got root privileges. You've got root persistent privilege, like access to the system forever until they unplug the internet or reinstall Windows. And I've tried to remove a WMI subscription from a laptop, like manually. It's a fucking pain in the ass. I don't know how to do it. It's so this computer's rebooted. We have a new agent because our it's still under our user privileges because we haven't escalated yet. But and if Windows Defender found something, it definitely stopped one because we only got one agent back. Or actually, I know why. I did it twice, right? The first time I wrote it to a key named updater, and the second time I wrote it to a key named updater. So yeah, it's just the one. But it's we can go find that. If we find that registry key, should be what, local machine, software, Microsoft. Windows, what is it? Windows current version run. Current version, and then run. We've got, so virtualbox tray.exe, Windows Defender. Why don't we have, because this is, it's under current user. We go software, Microsoft, Windows, current version, and run. Here we have our updater registry key that we created. So if we check that, it basically says when it gets executed, when the computer turns on, PowerShell, Windows hidden, encode, and then there's this X variable. But it's pointing towards another registry. It's pointing to this. You can see, Jesus Christ. It's saying execute PowerShell.exe, and you've got this variable here. Rather than executing a script now, it's saying execute whatever is in this registry key in current version debug.debug and execute that in PowerShell. So if we look at current version debug, we can see binary data. Yeah, you basically see this data here. That's our payload that's being executed. So we could remove that manually, but we could use the same module remotely. Say we don't have access to the system and we've done what we needed to do, but we needed to clean up after ourselves. I don't have to do it. You can clean up. If you set clean up to true, it'll go and delete that for you and remove traces of what it left behind. And so this is just one small example, but if you use that sort of concept for, it'll apply to pretty much every other module. So there's a shitload of other more complex modules. So lateral movement is a lot of what Chris talked about. I'm not going to go through too much more today. I'm just going to leave you with a shitload of resources. So if you really want to go further, you can do it in your own time. Because there's no way you can cover all of this shit in one day. But I just wanted to end today with at least, yeah, I don't know. You can start doing stuff by yourself if you've never played with this stuff before. CrackMap exec is probably the tool, alongside tools like Responder and stuff that Chris talked about. Watch the video here for crack map. This is when the guy demoed it at. Yeah, he'll run through the tool and you'll get an idea of what it can do with this. But if you're able to get hashes or privileges, you can use crack map to start executing all sorts of stuff on remote systems in the network. And if you have the right privileges, or if you find the right protocols that are open in the network and vulnerable to stuff, you could potentially just start executing agents, like executing payloads to create new agents remotely across the network, which is one way you can just move laterally throughout the network and infect more machines. There's a shitload of modules under the lateral movement directory as well. And these are basically the ports from the Powershell project. All of those PowerShell scripts that those guys have made, you can execute them through Empire on your agents. If you've pre-obfuscated them as well, there's a very good chance that they'll work. And you see all these sort of managery people talking about living off the land, and you'll hear antivirus vendors talking about living off the land, and everyone just says living off the land. What that means is essentially if the tools already exist in the place that you're hacking that will let you do what you want to do, why would you use your own tools and execute new programs in different code? Why wouldn't you just use those tools that already exist? And basically, that's what it's talking about. Because once you've sort of got a foothold in the network, if you're on a Windows domain, I guarantee that there are at least one of these which you'll be able to use to start screwing around with other computers in the network. So psexec is one that you'll see a lot. It was worked in a while ago. It's basically a tool that lets Windows administrators to very easily execute processes on other systems natively across all Windows networks, which is very good for us. That sounds exactly like what we want to do. If you've got admin credentials, it probably means that you can start executing shit on any box you want in the network. WinRM, it has to be running on the systems and listening for it to work. But here I've got the Empire modules that will let you execute stuff on those systems using that method. Or you can use crack map exec for a lot of that stuff too. Recon is probably a whole other session in itself, but watch these two videos. If you do nothing else, watch these two videos in your own time. They're like 40 minutes each. They're when the guys who created this Bloodhound tool introducing it, and they'll do a way better job of explaining it than I will. But it works in a living off the land sort of way. If you can execute their little program on a Windows computer on a domain, it will basically make on a network level, it won't look that strange, and it's extremely hard to detect this at a network level because we've been trying and we still haven't been able to set it up in a way that detects it at work. That machine will basically make a boatload of LDAP queries to the domain controller asking for all sorts of information. So it'll be asking things like what users exist on the domain, what computers are there on the domain, what users have sessions on computers in the domain, what users are part of what groups, which users have permission to change the password of other users. It just enumerates all of this stuff. It'll log it all into a couple of CSV files. If you can get that back to your computer at home, you can load it into this tool, and you can basically map out an attack offline across their entire network without touching anything else. And it's extremely easy to use as well. So watch the video and check it out. I wanted to demo it here today, but the only sample data I have is of our network at work, and I'm not showing you people that shit. So here's a screenshot of what the tool kind of looks like. So these represent users, user groups. There's no computers here, but essentially it'll map out all of this data, and then you can start navigating it as if it was Google Maps. You could say, if I'm this user, how can I get privileges to do this on the system? And if there's a pathway to do that it knows about, it'll just map it out like Google Maps. So this basically means that, so say my goal, I'm going to assume this is like a domain admin group, and everyone in this group is the domain admins. Say my goal is to get domain admin access on a network. Following this flowchart, these are all of the possible ways that I could get there. If I can get a user in this group, then they have complete, this is access control list stuff, complete access control lists to do anything to anyone in that network. If I was to compromise this user, they are a member of this group. They can change some metadata with this user, and then that user is a member of this group, and that would get you that. Now factor in computers and sessions as well, and you can basically map out your entire attack across the network very accurately offline. And then, yeah, this is my last slide, I think. I've talked for way too fucking long today. If you talk to blue team people or some smartasses, they'll basically, people nowadays are saying that PowerShell's dead. We've killed PowerShell. It was too dangerous for attackers, and we've locked it down. No one can do anything with PowerShell anymore. So stuff like Empire and PowerShell exploitation it's off. We fixed it. It's definitely harder than it used to be, but there are still, for every new protection that somebody creates for stuff like this, people always tend to find one or two ways around it. And once you've got a whole list of like 10 protections, you have to apply every single one to harden your network against that kind of attack. It's like the defenders have to cover every single possibility, but an attacker only needs to find one hole in the security or one misconfiguration to get through, and then they can do whatever they want. So even though it's a lot harder, if the right protections are in place, it's not possible to, So there's PowerShell version downgrade attacks. So that's basically like the latest versions of PowerShell have lots of security in them. But very commonly, older versions of PowerShell are still installed and supported. So as an attacker, you can basically say, hey, that's awesome, you want to use this latest version of PowerShell, but I would rather use the old version that has no protections. And a lot of time, that's a potential way that could work. Execution policy bypasses. There's some ridiculous shit that's happening right now where people are creating ways to interact with PowerShell, the PowerShell API at the Windows level without ever executing PowerShell, like the executable, or creating, it's insane. People are creating ways to use PowerShell without actually using PowerShell, if that makes sense. It doesn't really, but it's ridiculous. So PowerShell's not going away anytime soon. It's going to be very relevant in every Windows network for a long time to come, probably forever. Probably 90-something ridiculous plus % of networks in every business run Windows domains like this. So whenever you land a job in security or cybersecurity, whether it's your company that you're working to protect or whether you're testing the defenses of other company networks, this shit is really, you will need to know it. And if you do already, even if you don't end up using it in your job day to day, it's good to know. But is the pizza here yet? No? Yeah. They're already in Slack, but we'll do the whole post to online thing as well. But yeah. If you can come along next week, and if you have any questions about anything to do with the cybersecurity industry or what jobs there are out there or what you have to do to get them or any that kind of stuff, it's not going to be my problem. Direct them to the guest speaker. I think that's, all right, I'll stop the recording, but any questions? No, you're pretty sick of listening to me bitch on? Yeah, I think that was, yeah, it's about time.